Hi there. This is the second part of the lesson on bonds. So in the first part, we learned about bonds, what they are, and how to represent their economical analysis using just this formula here. And we introduced the idea that the values in this formula, especially F and P, will be different depending on the type of problem and the case you're dealing with. Are you buying a bond or are you selling a bond? So we kind of said that there are different type of problems if we're talking about the engineering economics course. And we'll see here examples for each one of these problems. So we'll start with the first one. So you are given F, R, N, and V, and the interest rate here, or the time value of money, and you're only missing here P. And that represents the case where you're trying to figure out the acceptable purchase price for a buyer who is considering to buy a new bond or a pre-owned bond. So let's see this example, this problem here. So there is a bond that has a 15-year maturity life and has a face value of 5,000, and this value doesn't change over time. It's just kind of a sticker on the bond. And the coupon rate is also another value that doesn't change, and we need to pay attention here. The coupon value is 6% per 6 months, payable semi-annually. So it's kind of, you can say 6% per 6 months. This is kind of redundant here because this is not per year payable semi-annual. It's actually per semi-annual payable semi-annual. So, so this means it's a period rate, and it was purchased for $7,000 8 years ago. So now in the present time, 7 years ago, that is how old this bond is. So this means it has left 8 years to the end of its maturity. And then there is so you have it was bought 8 years ago, so you have 7 years left to go with it to maturity. And the owner of the current bond, the current owner of the bond already got the 16th interest payment of this bond. So what it can be sold for now, if the buyer, now you're thinking you are the buyer, your desired rate of return here is 4% per month, per 6 months. So if I summarize all of that, I know the face value, I know the coupon rate, and it's a period coupon rate, it's not annual. And I know that the remaining periods of the bond here are, I know 15 years is the total maturity life, and I'm dealing with, my period is 6 months or semi-annual, so multiplied by 2. I have total 30 periods, but I already consumed 16 of them, so I'm left with 14 or 7 years left. If I keep the bond, if I buy the bond now as a buyer, and I keep it with me to the end, because it didn't say if I'm gonna buy it and sell it later or when. You assume that you're gonna keep the bond until it's the end of its maturity. So your F now, the value that you will get at the end of this cash flow, will be its face value, 5,000. And your I, the minimal attractive rate of return for you, is 4%, and that's per 6 months also, per period. One irrelevant information here is how much this bond was bought 8 years ago. It's not part of your cash flow as a buyer. So we're using the same formula here. Everything is given. V is given, R is given, and F is known. It's 5,000, the end of maturity. And you'll bring everything to the present by P given A, 4% and 14, and P given F, 4% and 14. So you just need to bring the values of the factors and calculate the purchase price to be around $6,050. So this means that the buyer, if the seller now asks for $7,000, that's not acceptable, because as a buyer, you will not be able to achieve your minimal attractive rate of return of 4%. Maybe someone else will be happy to buy it because they have less MARR. The second case here will be representing the case where you're trying to find the investment rate of return, or what we call the internal rate of return for a bondholder thinking about a bond. So they're given everything except for, now I have my MARR and I want to decide if I'm going to buy it or not. One way of doing that is you calculate the internal rate of return. So I have here a municipal bond, meaning that there is a municipality in a region or a city that wants to expand its municipal network or system, and they issued this bond. It's a pretty expensive bond, 20,000 bond, and it's offered for the sale of 18,000. So you see now the market is kind of changing the dynamics here of how much you can sell that bond, and they figure out that's probably a good acceptable price. The interest rate here is 6% per year, payable semi-annually. So this is now confusing here. Per year, payable semi-annually. So we have to do something here to correct that. And then the bond will be maturing and be redeemed at a face value 5 years from now. So this is the maturity life. If you purchase the bond, the first premium received in 6 months from today. That makes sense. You have decided that you will invest 18,000 in the bond if your effective annual yield is at least 8.16%. So now you're thinking, yes, I will take it for 18,000, but will it give me 8.16 effective annual return or not? So now, if we summarize all of that, I am given V, I'm given R, I'm given the purchase price. R here 6% per year per semi-annual. So this means that I need to bring it to the period, which is semi-annual, so I divide by 2. So 6% divided by 2. And then N is 5 years, but my period is 2 periods a year. So in total I have 10 periods. And then the desired effective annual rate of return is 8.16%. So here I'm giving everything except for I. I will get I compare it to then 8.16% MARR. How to get I? The internal rate of return, we figure out, let's try all the values that will result in that present worth. So now bringing everything, so bringing this 18,000 to the right side of the formula, and that will be the present worth. And I want this present worth to be equal to 0. And I will look for I that will make this happen. And that I value that will make this happen is called IRR. So I tried different factors here, different rates. So 4% resulted in positive present worth. I don't know if I go up or down, so I tried the downward, kind of reducing the rate, and that resulted in increasing the present worth. So I now figure out I have to go to the other way, the opposite side, which is increasing the rate to 5%. And you can see here now I flipped the sign of the present worth. So this means the IRR is between 4% and 5%. That's actually here something I have to correct. So it's between 4% and 5%. And in this case here, so if using now interpolation between 4 and 5%, I'll figure that my IRR is 4.258% semi-annual per semi-annual. Now my MARR is given as an effective annual rate, 8.16%. So we found the period interest, so we need to move this from period interest to be effective annual interest to be able to compare to MARR. And we'll do that using the effective interest rate formula we learned in a previous lesson. So it's equal to 1 plus the period interest to the power number of periods per year minus 1. That will bring us now the effective IRR to be 8.7% per year. Comparing that to the 8.16% MARR, I see now IRR is more. So now the conclusion would be, yes, buy the bond. You will get your MARR and even more. The third and the last case is we're given everything and we're looking to calculate F, which represents the case when you are trying now to sell the bond and trying to figure out what's the acceptable sale price. So let's see this exercise here. So we're given here the purchase price of a bond that has a face value of 10,000 that was bought by you for 9,500. So you kind of got a discount on it. You purchase immediately after the previous owner received the semi-annual interest rate. The bond rate is 6.6% per year, payable semi-annually. So again, another confusing rate here, so we have to fix that. You plan to hold the bond for 5 years, selling it immediately after you receive the interest payment. So you will keep it for 5 years with you. If your desired annual yield, or the time value of money here, is 12% per year compounded semi-annually, we have to deal with that rate here, per year compounded semi-annually. What will be your selling price of the bond? So meaning that you're selling it, you're not keeping it to the maturity end. So to summarize all of that, my face value is 10,000. I bought it for 9,500. My coupon rate is 6%, 6.6% per year compounded semi-annually. So that translates per period now to be 3.3%. I have 10 periods in my cash flow, and my time value of money is 6% per period, or per semi-annual. And I will see the formula here. I'm given everything except for F. So I'm giving P, I'm giving the period return, V times R, and dealing with the factors, bringing these factors from the tables or using their formulas. We'll figure out now that the sale price that will be acceptable, which is now, this is the minimal sale price, is 12,663.5. So if someone comes and offer me 14,000, I'll be super happy. All right, so that's the end of it. We've seen different cases of analyzing bonds. You might be owning a bond and you're trying to sell it, so you're looking for the F value. You might be looking to buy a bond and look for investment, and in this case you are trying to figure out the P purchase price, the maximum you should put in that bond. Or another way is you have your MARR with you. Don't use it in the calculations and assume I to be unknown. You are given, you are negotiating, and the other side proposed you to buy for a price. Now P is known. So now that turns out to be an IRR problem. All right, so that's the last part of this lesson. And in the other lessons, we'll learn about loans, and we'll learn about depreciation. So wait until these videos. Thanks for watching. Take care of yourself and those around you. Take care.